Hello, my name is Dmitrii Misharov. I'm a DevOps engineer at OpenSSL Corporation, and today I would like to talk about my CI/CD adventures with GitHub Actions, Google Cloud, and GitHub Enterprise, actually at OpenSSL. So let's start from the beginning. So I guess every one of you knows what is OpenSSL, yeah, and where its sources are located. They are on GitHub, but the thing you might know that sources, that repository is a public mirror, and it's a public mirror of the private repository, which is located on our self-hosted GitHub Enterprise instance. It's done due to various security implications, but as many other projects, we also use CI/CD to test incoming changes. And the problem was that private and public repositories were using different CI setup. If for public repositories on GitHub.com, we use GitHub Actions. For private repositories at GitHub Enterprise, it was used so-called build-bot CI, and it was really uncomfortable and big maintenance burdens to keep maintaining two different CIs for mostly the same repositories. It's also worth to mention that we had an account at Google Cloud Platform, which we will use to build our CI/CD solution for this CI for both private and public repositories. And was my mission actually to unify the CI and make it awesome without burning the cache. The problem was that GitHub Enterprise cannot use GitHub hosted runners. That was bigger problem, so we cannot just switch the button and use GitHub hosted runners. No, it doesn't work like that, but what is working, GitHub.com allows you to provision your own runners, they call it self-hosted runners, on your infrastructure to run CI jobs. And there are basically two possible ways how to provision these runners. They just could be a service running on operating system. The way how you can provision this operating system is just running a permanently running VM or dynamically provision VM based on the when CI job starts and spin up that new VM. So why not use that permanent VMs? Yes, it's simple to set up. You just can create your own fleet of VMs and runners on them, but it is inefficient because you don't know how many runners you need in certain time of moment, and just most of the time the VMs will be idle, and they just will be wasting the money, which we don't want to do. And also permanently running the runners can cause some security leaks and problems that happened in the past. For example, PyTorch case actually was exactly with permanently running GitHub Actions runners. Yeah, that we don't want to. We want to avoid all this. So it's obvious we want to go to dynamically provisioned VMs. And what's the pieces of that approach? It will be, of course, webhooks, which GitHub emits. We will use it heavily in our solution. We need some dispatcher service, which will listen for these webhooks. And this service will provision VMs. And when job finishes, that VM will disappear, just like that cat Batman. Yeah, and how it works in details. So when the job starts, GitHub Enterprise emits a job started webhook, and our dispatcher service handle this webhook. And based on our CI's configuration, it communicates with the cloud provider, in our case as a Google Cloud, and provision a VM with a pre-installed runner. When the runner is started, VM is started, runner registers itself against that GitHub repository as an ephemeral runner. Then it waits for a job. One is get the job from GitHub. It's run the job or fail the job. It sends the signal back to GitHub. The job is completed. And simultaneously sends also signal that it should be unregistered, so it will be not stayed with it in that repository. And GitHub Enterprise back sets another webhook to our dispatcher, and dispatcher again communicates with cloud provider and says, please destroy that VM. So that's basically the flow, how that dynamic approach works, and how we used in our GitHub Enterprise instance. And this is a small diagram. So it's really simple, nothing fancy. We have a GitHub repository, our dispatcher service, which is running as a service on also on Google Cloud, which can communicate, spin up VMs and containers, which I will talk about later, how we will run containers with that setup. So what is the dispatcher? So dispatcher, I wrote it as a simple Python fast API application. It's a listen for GitHub webhooks. Webhooks, it's just a JSON payload, which we parse it, and based on CI configuration, we spin up a VM image, which can be whatever you build it, and deploy it. It deployed as a cloud run service. It's fully stateless, no DB required. So it's pretty simple application, but still it requires some maintenance because it's a web application. It has some release lifecycle and needs to be packed, in our case, in a container image, distributed, and all other things which you need to do with the applications. And also, it's worth to talk about why we want to use VMs at GitHub Actions runners. Because, for example, GitHub Actions can be spawned in containers, it's written in their documentation. They even provide some their own dispatcher. But in our case, it doesn't work. There is too many reasons for that. One is that we want to be close as possible to GitHub, public GitHub repositories, which use GitHub Actions infrastructure, which also uses VMs. And another reason that Windows, it's not practically to run them in containers. It will be much make complicated setup. So just VMs is a simple thing to run our CI setup. But for other repositories which are not related to OpenSSL, but also is also is hosted in our GitHub Enterprise instance, provisioning VMs is more expensive than running jobs in a container environment. So VM-based jobs start in approximately 2 minutes. It's because of all this VM initialization, requires so much time, and only after that our GitHub runner will start. Whereas containers start really fast. In 30 seconds after job triggers, you will start it running. It's also optimized the cost of and performance. Running CI jobs in containers much cheaper than in VMs. But there are some limitations. For example, you cannot use Docker within these container jobs. But I found some workaround. Podman and Builder, this another container engine implementations, works perfectly fine within Cloud Run environment. So we can build and run containers within containers. No issues with that. I was talked actually about our first implementation. It was based on this self-hosted, fast API application, which I was previously talked requires its own maintenance. Later, we switched to GCP Cloud Build. It's another Google Cloud piece of, I would say, infrastructure, which simplified the system further. So first of all, you don't need to run in a web application. Cloud Build natively accepts webhooks, so it listens for webhooks. It's designed for that. You can configure which part of that payload you want to use as environment variables, and just feed it to your some script or logic, which will deploy to this cloud build instance. Yeah, and after that, in that logic, you can write some script which will spin up the container or VM or whatever you need. And it's even more cheaper because there is no any running service. Cloud build running, costs nothing. So you will pay only for container jobs, which also depends, on your workloads. Yeah, and the diagram, it's from setup perspective, nothing changed. We just replaced the dispatcher, which was running on cloud service as cloud build, but in our infrastructure as a service, nothing changed much. It just switched one thing to another, so it was quite easy. And the final results, so we have this cost-efficient solution, so we don't have idle VMs which wasting the resources. We have unified CI configuration for both public and private repositories. So they use the same workflows, and we didn't need to invent some wheels. Just use the same configuration. It's secure. Each VM is is ephemeral. By this way we reducing attack surface, so there's no any rogue services running aligned with our permanently running runners. Also, we have faster execution for some suitable workflows. So containers are helping here, and combining these both approaches, dynamic provisioning of VMs and containers provides our best balance of cost, speed, and flexibility. And that's it. So if you have any questions, will be glad to answer.